Hello everyone, welcome.
Hi. Je me connecte, sinon je perds le webinaire.
Welcome for this second day of the training workshop dedicated for the Mediterranean Sea, organized by the Copernicus Marine Service. I hope you enjoyed the first day. Now this second day is dedicated for practical session, so we will dive into the data through different e-learning material we developed for you. Let me introduce the speakers. So my name is Fabrice Messal. I'm a UX and Capacity Development Manager at Mercator Ocean International. And Ergane Fouchet from Noveltis is here with me today to moderate and animate some session. Hi, Ergane.
Hi, Fabrice. Thank you all for attending this session. So yes, I'm an ocean engineer. I work at Noveltis, and I'll be animating and presenting the Jupyter Notebooks.
Okay, let's go. This is a very long session. We have 3 hours of a session today. So let's start now. So the content of today is a session with Jupyter Notebook tutorials presented by Ergane. After the coffee break, we will have tutorial on MyOcean Viewer Pro made by Chloé, and then Simon will introduce you QGIS tutorial developed for this specific session on the Mediterranean Sea. For each Jupyter Notebook and QGIS tutorials, you will have the entire presentation of the Jupyter Notebook and QGIS tutorial for the beginner. After this, a Q&A session, and then an introduction for the advanced tutorial on QGIS and Jupyter Notebook for each part of this presentation. On the Padlet, you will find all the presentation from yesterday, and the recording will be accessible. The recording of the previous day will be accessible this afternoon. Don't hesitate to dive into all this information on the Padlet. There is a lot of information, and also the link to access the Jupyter Hub, where the Jupyter Notebook are hosted. And yes, on the map, you have a map on the Padlet, and you can pin your location to see where you come from. So, okay, there is a lot of people from the Mediterranean basin. This is normal, very normal, very common. So we are very pleased to have you on board for this second day of this session. Just a reminder about the question and the rules to ask your question. Don't use the chat of Zoom. Use the Slido. The link will be provided for you in the chat. All the questions will be collected. We will try to answer the question during the day, but if we don't have time to answer all the questions, don't be worried. We collect all the questions, and the experts will answer the question after the webinar, and the question and answer will be accessible on the Padlet at the end of the webinars. So let's start now with Ergane. We'll introduce you the Jupyter Notebooks tutorial for beginner and advanced people.
Okay, can you see my screen?
Yes.
Okay, great. So just like Fabrice said, I'm going to present you the exercises we have developed for Python and for Jupyter Notebooks. The first thing to do if you want to access these exercises is to access the Jupyter Hub, and you can find the link to the Jupyter Hub from the Padlet. Here you have Jupyter Hub access. And when you click on this link, you will be required to enter your Copernicus Marine Service credentials and then you will reach the Jupyter Hub. So this is how the Jupyter Hub looks like. So this is my workspace, but you have a public folder which is entitled Shared Notebooks. Maybe you want me to zoom more. I don't know if you see better now. So
yes, it's better. Yeah, thank you.
You have a directory entitled Shared Notebooks, in which you can find all the training material which have been developed for the previous workshops. So you have the 3 workshops we've had this year, so the Arctic, the Baltic, and the Mediterranean that we're having today. You also have the regional training that we made in 2020, again for the same regions, and we have the trainings for the global ocean, so Africa, America, and Asia. So obviously the training we're interested in today is the training Med 2022. And you can see that we have developed 2 exercises, one dedicated to beginners and one for intermediate level users. In this public folder, Shared Notebooks, you do not have the rights to write in this folder. I do not have these rights either. So the first thing to do is to copy this folder into your work directory, to your own workspace. And to do so, you have to open a terminal here. And then you write the following command line, copy the directory. It's in Shared Notebooks. It's called Training Med 2022. Then you add the dots and the directory will be downloaded into your workspace. So here is mine. As I said, we have 2 notebooks, the one for beginners, the one for intermediate level. And so today I'm going to present you the whole notebook that is dedicated to beginners. The notebook which was developed for advanced user has already been recorded in a video, and it's available on YouTube, and you can find the link to this video on the Padlet. So it's already available. So today I'm going to present you, I'm going to present you the exercise for the beginners. If you're not familiar with Jupyter Notebook, this is how a notebook looks like. You have figures, you have text, and you have code cells. So these are Python code cells. And if you want to run a code cell, you can either click on the arrow on the top menu here, or you can use the keyboard shortcut Shift and Enter. And also, if the notebook stops working, you can try to restart it by clicking on the loop arrow on the top as well. So let's have a look at the agenda of this session, of this first exercise. So now we're having a quick introduction. Then I'm going to present you the data that we are going to use. Then I will show you how to access this data, how to download them. So several options for you to download the data from the Copernicus Marine Service. We'll learn how to explore the product with Python. And then we will learn to make basic plots, basic figures, so maps, time series, etc., with the example of the sea chlorophyll concentration in the Mediterranean Sea. So that's it for the program of the exercise for the beginners. Before I start, I suggest you do not do the exercise in the same time as I do, because this video is being recorded, and within a few days it will be available on YouTube, and you will find the link on the Padlet. So I think you will benefit more from this presentation if you just attend and not reproduce the exercise. You will have plenty of time to do it on your own later. So As I said, the objective of this exercise will be to analyze the chlorophyll in the Mediterranean Sea. To do so, we're going to use 3 different products, from a model product, from a satellite observation product, and from an in situ product. So the model product that we're using is called Mediterranean Sea Biogeochemistry Analysis and Forecast. The satellite observation product has a very long name. It's the Mediterranean Sea Monthly and Daily Interpolated Surface Chlorophyll Concentration, blah, blah, blah. And finally, we have the chlorophyll time series from a mooring instrument. So this is an in situ instrument. For the model and satellite products, if you click on the links here, you will reach the Copernicus catalog, and you will find the documentation webpage of the product. On this page, you can find plenty of information about the product. You have a short description, you have the geographical coverage, the temporal coverage, the temporal resolution that are available, and most of all, you have the variables. So this is what you are usually interested in.
Sorry, again.
Yes.
We have some noise and we can hear you very well. I don't know if it's perhaps a mobile phone.
Is it better now?
Yeah.
Okay. Do not hesitate to interrupt me again.
Yeah.
Sorry.
Yeah. Okay. Thank you.
Okay. So for the model and the satellite products, we have downloaded the products from the catalog. But for the in situ observation, well, the users and even I often struggle to download the products. Hopefully, we have 2 notebooks which have been developed by Paz Rutland for the previous workshop in 2020. And these notebooks are very useful and very well designed. You can find them, you have the links to these notebooks here, or in the Access in situ. So here are the 2 notebooks. In the first one, you have an extensive description of, I'm sorry, this is quite long. Okay. You have an extensive description on, no, they're here, sorry. Of the in situ products. And in the second one, you have, I'm sorry, this is quite long. And in the second, second notebook, you will learn how to subset and download the product. So basically, the in situ observation, whatever region you're interested in, it's a huge data set, and you subset it by applying several filters, and then you can download the products that you're interested in. So usually we have plenty of questions on how to access these products, the in situ product. So I suggest you have a look at these notebooks. I won't have time to present you the whole notebooks now, but they are available in the training. So let's go back to our exercise for beginners. Before we start to see how to download the products, I would like to remind you that all the products all the files that we are going to use, they have already been downloaded and they are stored in the data folder here. So you do not need to download anything in order to do these exercises, for both exercises, either for the one for beginners or for advanced users. But if you want to download, if you want to study another region or another period or some other variables, you may be interested in downloading some other files, some other products. The first method I will present you is from the catalog. In my opinion, is the easiest way to access the Copernicus Marine Service. So here you have a link to the catalog. You also have a tutorial video which explains how to reach the catalog. If you go back to the here, if you take the documentation webpage from the Copernicus Marine Service, you will find that there is a data access section. Here you find all the data sets that are available. So here, if we want to study the chlorophyll with monthly resolution and 1 kilometer resolution, you click on here. You're required to enter your credentials. And then you can apply plenty of filters. So you can select the geographical area you're interested in. You can also select the time range you want and the variables. So here the product I'm showing you is only has the surface chlorophyll, but sometimes you also can choose the depth range. And then once you have selected all your criteria, you can click on download and the product will be downloaded on your computer. The second option I will be presenting you is the MyOcean client. This option is very useful because you can download the products directly within Python. So it's especially useful if you want to download several files to make a loop on either the variables or the dates, etc. So this can be done directly from the Jupyter Notebook. Again, you have a dedicated web page which explains how the MyOcean client works. But very briefly, the principle of this method is that first you reach the MyOcean client and the Copernicus Marine Service website. You select the product and the data set you want. Then you select the mean and max latitude, longitude, dates, and depth if the depth is available. You select your variables, you set the output directory, output file name. You have to set your username and password from the Copernicus Marine Service. And then the file will be directly downloaded in your directory, on the Jupyter Hub. So this command line may seem complicated, but if you go back to the catalog, once you have selected all your criteria, you can click on download options and then view script here. And here you can find the command line that matches that describes all the criteria you have selected. So that's it for the MyOcean client. The next option is the FTP method. And the example I will use for the FTP comes from a very new product, which is the nutrient profile vertical distribution. Here is the link to this product. So, well, this is a very new product. If you click here on data access, you will find that this product can only be downloaded from the FTP. So if you click here, you will retrieve the address, the link to the FTP, and this is what we're going to use in the notebook. The principle of the FTP is that so first you import the libraries, then you set your username and password. You connect to the FTP server from the Copernicus Marine Service. This link refers to the link you retrieved from the catalog just before. And so the principle of the FTP is that you reach a folder, then you list the files or directories that are in this folder. Then you go to another folder, you list what's available, etc. And you do so until you reach the netdf file you're interested in. You have to know that in the FTP method, you will not be able to filter. You cannot apply any filter. Usually the products refer to a year, a month, or a day of data. And so here, for example, with our product, you can see that we have a directory for each year from 2002 to 2020. And if we go, for example, to the directory 2020 and we list the files in it, you can see we have one file per month. And so if we select one file, so the one from February, for example, then you can download it and the data is downloaded directly into your workspace. So our very last method to access the Copernicus Marine Service products is the OpenDAP method. So in all the previous methods, at the end of the process, we had downloaded, like physically downloaded the product. It was available either on our computer or in the Jupyter Hub. In this method, we do not download anything. We do not store anything. So it's very convenient because the files sometimes can be very, very huge, very heavy. In this method, we stream the product. We use it remotely. And all you have to do is to retrieve the address of the FTP. So again, you go to the catalog, the data access, you click on the API and you will find the link to the OpenDAP. So it's very easy. I will show you an example just after this of how to use the OpenDAP method. So this method is very convenient. Yes. So now that we know which product we're going to use and how we can download them, we are going to explore them with Python. The first thing to do when we work with Python is to import the libraries. So here is the list of the libraries we're using in this notebook. First, we're using NumPy, which is a very basic library for scientific computing in Python. Then we're using Xarray, which is used to manipulate the netcdf files within Python. We are using Matplotlib for the figures and the library Cartopy for the maps. All these libraries are very widely used. You can find the documentation webpage on the links. So here for NumPy, for example, you have the documentation webpage. You also have plenty of examples on the internet, and so you shouldn't have trouble for whatever need you have. So, well, they are very widely used. But if you do have some problem, do not hesitate. I will show you the email address at the end of this notebook for you to send us your questions. And so, yes, do not hesitate if you struggle with anything regarding the notebooks. So in this cell, we import the libraries that we need. And so now that the notebook is set, we can start to load the files. So as I said, the files are already stored in the data folder. So we have netcdf files here. And so the first thing to do is to define the path to these files. So this is what we do here. We set the path to the three products we are using. And then we are using the Xarray method open dataset. If you click on the link here, again, you will have the documentation page of this function. And here we open the product and we store them into some Python variables. In this cell, we do what I was presenting you before, the OpenDAP service. So as you can see, instead of having a path to the product, you just have the address we retrieved from the catalog. And you will see that it works just the same. As I was saying before, all the products you download from the Copernicus Marine Service, whatever method you choose, they are all netcdf files. And so netcdf files are a very basic way of storing data. They consist of coordinates, dimension, and variables. So here, for example, we take the satellite observation variable. We can see that the dimensions are time, latitude, and longitude. Sometimes you also have the depth as a dimension and the coordinate. And you can also have a look at the variables. If you click on this button here, you will access the attributes of the variable. So you have the long name, the units, the min and max values, etc. And if you click, let's take for the time, for example, on this button, show hide data, you can find all the values that are represented. So here, for example, you can see we have 5 date times, etc. Just to show you that the OpenDAP works just the same. Here we had stored the OpenDAP product in this variable, and you have the same kind of information, except that the file that we had downloaded, we had subset it because we cannot download very huge file in the catalog, but with the OpenDAP service we can. And so we can see that we have more time dates and more latitude and longitudes, and we also have all the variables available in the product. So if you want to study one specific variable, so you can see, for example, in the OpenDAP product, we have several variables. If you want to study only one of them, you can select the variable by using either dot and the name of the variable, or this way. So they work just the same. And if you do so, you can see that you now only have the variable, you only have the chlorophyll, and you no longer have the other parameters. With this method, you, however, keep the information on the coordinates, so you still have the time, latitude, and longitude. But if you want to access only the data in the shape of an array, just like you would for an NumPy, if you put the data, you will see that you only have the values. So here we have not a number, because these not a number values refer to the landmasks. We do have data in this product. Okay, now we can begin to study the Mediterranean Sea chlorophyll concentration, because now we know how NetCDF files work and how Python can be used. The first thing that we will be interested in is to subset the data set. As I was showing you before, the products contain many date times usually. And if we take again the satellite product from the OpenDAP service, we have 15 date times that are all listed here. And we may want to select the product at just one date time. So this is what we are going to learn. We have several examples here, depending on the situation you're in. You can either, if you know the exact date that you want to study, so if you want to study especially the 1st of November 2021, this date is represented exactly in the product. So what you have to do is to use the xarray.cell method and then specify time equals the date you want. And if we run this cell, you will see that we no longer have a time dimension because we only have one value now, but the time is, the time that has been selected is the date we have specified. However, if you do not know the exact date, well, if the date you're interested in is not represented, let's say if you want to study the 5th of November, the 5th of November is not represented in the product. So you have to specify a method. So here we choose to take the nearest one, but you can also make a linear interpolation to study, to select this date. And so if we run this cell, you can see that it has selected, we had chosen the 5th of November and it has selected the 1st. You can also choose to select the date from an index. with the index. So if we want to take the index 9 of the time, we use the iCell method. So it works just the same. And then the index 9 refers to the same date. Finally, the last example is to select a range of date. And to do so, you can use the method slice. So again, it's the dot cell method, time equals slice. You put the start and end date. And if we do so from August to December, you can see that indeed the dates at the end go from August to December. So here I've shown you the examples for the dates, but these methods work for all the dimensions, so the latitude, longitude, and depth as well. So now we can start to plot our very first map. We are going to plot the sea surface chlorophyll on January 2022 from the satellite observation product. So when we want to plot figures, we have to check first the name of the variable, because sometimes the latitude is called lat, sometimes it's called latitude, etc. So this is very useful to plot the variables before making your map. So here is what we do. We select the satellite product. Here we select the chlorophyll variable. We select the time from January 2022. Before starting to see the technical details of the code, I will show you the result because it will be easier for you to understand. So here we are plotting the sea surface chlorophyll in January 2022. The color refers to the chlorophyll. The units is milligrams per cubic meters. And that's it. So first we create the figure. We add the axe and we define the projection of the map. We add the coastline. This is the line, the black line here. We add the grid lines. We remove the labels of the latitude and longitude at the right and at the top. So here we do not have the labels, as you can see. We add the landmass and we set the extent, so the geographical extent we want for our map. So this is the min and max, longitude and latitude. To represent the chlorophyll on the map, we use the function pcolor. Then we specify the longitude, latitude, and the chlorophyll. We set the min and max values and the color map. So the min and max value go from, well, the values go from 1 to 1.2, and this is what we have here. So very quick analysis of this map, we can see that the chlorophyll in January 2022 bloomed, especially along the Italian coast in the Adriatic Sea and in coastal region, generally speaking. The blue cells refer to exercises we propose for you to manipulate the code. You can try to visualize some other parameters from some other product. You can try to zoom to change the extent here, to change the extent of the map, to zoom in a specific region. And you can change the color maps and the min and max values, etc. The next plot we are doing is the time series. So we are going to do this time series from the in situ product. So this is the mooring. This is what the mooring file looks like. So you can see that the coordinate and dimensions are not as easy as for the satellite and model products. But still, we can see that the location of the product of the instrument has remained the same. So we have only, well, the instrument has not moved. We can see that we have some, well, plenty of variables. The one we're interested in is this one. you can see that it refers to the chlorophyll, and you can have a look at the units as well. And so here is the map that we are going to plot. Again, I'm showing you first the result, and then I will show you how it works. So at the bottom on the x-axis, we have the time. Here we have the chlorophyll concentration. We have a subtitle which tells the latitude, longitude, and depth of what we are studying. And on the top right corner, we have a mini map which shows the location of the instrument. What we do is that first we select the longitude and latitude and depth in order to put it in our title. Again, we create a figure, we create an axe, we add the grid. So this is the grid. We add the title and the subtitle. This line is very useful to format the dates in the x-axis. So it appears clearly and well, you can read easily. And then we use the plot method. So in the x-axis, we have the time, and in the y-axis, we have the chlorophyll concentration. Here is how we add the minimap on the top right corner. We add the axe and the projection of the map. We add the grid lines, we remove the labels on the top and on the right. And then we use the function scatter, which put the dots where the instrument is located. So on this plot, we can see, for example, that the chlorophyll concentration bloomed in November 2020. We have, well, it strongly increased in this period. What you can do from an exercise we suggest, what you can do is you can zoom, for example, on the peak here, or you can again study another variable or well, from another product, etc. The next plot will be a vertical profile, chlorophyll profile from the model product. So here is how the model looks like. We have the dimension depth, time, latitude, and longitude, and the variable chlorophyll. What we're going to do is that we're going to select one location. So we set one longitude and one latitude. And we select two dates, January and February 2022. We select the chlorophyll, so at this location and for the two dates. So this is the result of the, so this is what the values look like. And then we can plot the profiles, the vertical profiles. So again, here is the result first. We have, well, the x-axis refers to the chlorophyll concentration with the units. The y-axis refers to the depth. We have the blue line, which refers to January, and the orange line to February. And again, we have the map, which shows the location of the profiles we're studying. So again, we create a figure, we add the labels and the titles, etc. We have this line which reverses the y-axis so that the surface appears on the top. Then we add the minimap just like we did before, and we save the figure. So what we can see is that the chlorophyll was well, was larger in January than in February, and that the concentration is higher at the surface than in the bottom. This is basic analysis we can make from this figure. Again, you can try to study some other date, some other region. Well, if you change the parameters here, you'll be able to change, well, to visualize some other data, and maybe find some other interesting information. The X-array datasets are very easy to manipulate. You can apply any operation you want on the dataset. And so, for example, if you want to calculate the difference between these two profiles, you just have to write this line, the chlorophyll from date 1 minus the chlorophyll from date 2, and you will have the result. Here is an exercise we suggest. You can reuse the script from the previous section and plot the difference on a profile. The next plot we are making is vertical slices. Again, we are using the model product. Let me show you the result. The aim of this plot is to create a line, so here in the Adriatic Sea, and to see how the chlorophyll concentration evolves along this line and along depth. So on the x-axis, we have the longitude. The y-axis refers to the depth, and the color map refers to the chlorophyll concentration. So again, how did we create this figure? We selected the min and max longitude. The latitude is, however, remains the same along this line. We select one date, again, January 2022. We select the model at this date. So, at this latitude, along the longitude we have set, and at this date. We create the figure at the labels, title, etc. Again, we reverse the y-axis. And then we use the p-color function as well as we did before. The x refers to the longitude, the y refers to the depth, and the colors refer to the chlorophyll. Again, we set the min and max values of the color bar, and we set the color map. We add the color bar, set the label of the color bar, we add the mini-map, and we save the figure. So what we can see is that in the more coastal regions, where in shallow waters, the chlorophyll is higher than in deep waters. Sorry. And that's it. So what you can do, another exercise we suggest, is for you to change, to study another line, another region, or again, another parameter. The last cell creates an animation. So we are going to use again the first map that we created. So the map of the sea surface chlorophyll, and we are going to make a loop on all the values in order to see how the chlorophyll has evolved. How it has evolved with the month along the year. So we create a loop with all the dates included in the satellite product, time values. And this is the same script as before, except that when we select the model, we select from the date. We do not specify one date, but we do it for all the dates. And then we save the figure. We save each figure for each date. And then this last cell will merge all the figures that we have created and save it in GIF format. And so, it stops working. Okay, but if you go, it has been saved in the out directory. And if you have a look at it here, you can see how the chlorophyll, the sea surface chlorophyll, has evolved in 2021. So that was our last figure. So we have learned in this notebook how to access the products, how to manipulate them with Python, how to see which variables, coordinates, dimensions, etc. they contain. I'm sorry for this. And so again, if you have, we have plotted also plenty of figures. And again, if you have some questions, do not hesitate to send us a question. Here is the mail address, so servicedesk.siemens@mercatorocean.eu. And that's it for the first notebook. Maybe we can have, well, maybe I can take some questions before presenting you the second exercise for advanced users.
Yes, okay. Thank you, Ergane. It was very interesting. I hope the participants understood your explanation. For me, it was very clear, but I'm not the target of this of the notebook. So I hope you enjoyed this session. We have several questions on Slido. Let's share my screen. Perhaps we can just answer 2 or 3 questions and then continue. And again, all the questions will be collected and we will answer the question after right after the webinar. So don't be worried about your question. So how can we access the Jupyter Notebook?
From the Padlet, you have a cell which is entitled Access Jupyter Hub, and then when you are on the Jupyter Hub, you have a notebook folder or shared notebooks in which the training for the Mediterranean Sea is available. Yes, and so you will have the link of the Padlet on the chat. And the second question is the command line to copy on the folder, the Jupyter Notebook. I know on the discussion on the chat, on the Zoom chat, someone answered this question directly, giving the key, the code. But I think there is also a participant manual. Yes, exactly. And this will answer the second question. Well, this is the second question, the command line. Yeah. This is how you, well, it's written in the participant manual, sorry. Yes, so on the Padlet, you have access to a participant manual, which is a PDF file. And on the PDF file, you have all the command line to copy the folder on your home directory on the Jupyter Hub. Okay. Yes. How can I get access to the files of training in order to try them after the Zoom meeting? Yes, through the Padlet. Again, this is the same kind of question. How do you manage to add the cost lines to the plot? Is it an extension or a function? It's included in the library Cartopy. You do not have to download anything. Once you have Cartopy, you can use the command line, the line, which the Python line from my cells, and it will work. You do not have to do anything else. Okay. How can you know which are the mean and max values to select the correct range? Usually you just try and adapt. That's what I do. Once you can read the values that you want, then these are the min and max values you need. There is no single recipe to find the correct min and max values. You have to test. How can we save the plots? For example, the mooring example, including the plot with the time series and the small map on the left corner and the subtitles. I did not present this, but when you do PLT, well, for matplotlib.savefig, you put the path to the the figure that you want and specify the .png, and the figure is saved. But all the figures that we make in the notebook are saved, so you can find the line the command line. This. Okay. Okay, and we will answer the other question later. There is some question about R and the seal and mask. For example, I would like to know where I can download the Mediterranean seal and mask.
at 4 kilometers and 1 kilometer of spatial resolution. So, okay, we don't have this file directly accessible now, but if someone from the audience have this info, and I'm pretty sure that a lot of people who attend this meeting have this information, don't hesitate to share your tips and tricks and your links to find this kind of mask. Otherwise, the service desk and the user support will answer this kind of question. Okay, let's move to the introduction of the Jupyter Notebook for advanced people.
Yes,
okay.
I share my screen again. Okay, so as I said in the introduction, the notebook for advanced users covers a real case scenario, which is the marine heat waves in the Mediterranean Sea. So very briefly, so the heat waves are very well known, especially now, I don't know where you are, but this month of May is very warm, in France at least. And so the heat waves are also, well, they also occur in the seas, in the oceans, and they have been studied for, well, only since 2016, so it's very recent. So the first definition was given by Hopday et al. In 2016, and this definition is that marine heat wave is well, consists in a period of at least 5 days when the sea surface temperature is higher than the 19th percentile threshold of a sea surface temperature climatology. So this is the definition we're using in this notebook. And well, this is a figure that shows that the maximum intensity of the sea surface temperature has been rising over the years. The Mediterranean Sea is one of the, well, in the frame of climate change, the Mediterranean Sea is warming faster than most other regions in the world. This is what this figure shows. Again, we set Python, well, to study the marine heat waves. Again, we set Python with plenty of libraries. The difference is that we have, for this notebook, we have a specific library, which was developed by Hopday et al. And this library is called Marine Heat Waves. If you click here, you will find the documentation webpage. I'm not going to show you all the details, but the principle of this notebook is that we load a 20-year-long time series of the sea surface temperature from satellite observation product. Well, I forgot to tell you that, well, I did it in the introduction, but again, it has been recorded, and the whole presentation of this notebook is available on YouTube and on the Padlet. Here is a map of the sea surface temperature in June 2020, for example. Then in this section, we pre-process the files because the library we're using, the marine heatwave library we're using, expects some specific format for the files, for the variables. In this section, we calculate the marine heat waves over the whole Mediterranean Sea, and we are using the function detect from the marine heat waves. It enables to have plenty of information on the marine heat waves. We have the, well, if you put, well, the input is the time series, so the sea surface time series of 20 years. And over these 20 years, you have all the events that occur, all the marine heat waves event. And so here with our 20-year-long time series, we can see that 37 marine heat waves have been detected between 2001 and 2020. We can also find information on the largest event. So we have the maximum intensity that is almost 2 degrees above the threshold. This marine heat wave, the maximum marine heat wave, well, lasted for 25 days. it occurred from, well, in June 2003. So this event refers to a heat wave that occurred in the atmosphere as well as in the sea. And it's a very, well, quite a famous event in the region. What we are doing here, so this very long cell plots this figure. So we on the top figure, we have the sea surface temperature. So this is the black line. We have the climatology. So this is the blue line, and we have the threshold. This is the green line. We make a zoom here on the year 2003. And the parts that are colored in red show the worst marine event, and we can see that it has been followed by a second marine heat wave in September. So that's it. In the previous section, we were studying the whole Mediterranean Sea. Now we are splitting the Mediterranean Sea into two parts, the Eastern Mediterranean and the west part of the sea. Again, we are calculating the statistics, well, the occurrences of the marine heat waves in these two regions. And so, as we can see, the two regions were not affected in the same way. The western part, for example, the eastern part, sorry, was not more affected by the heat wave of 2003, but it has seen a marine heat wave in 2018, which lasted for 61 days. So the aim of this section is to see that depending, well, it's not always relevant to study a whole region, especially if you're interested in smaller regions. You can see different things. And finally, this section shows you, these maps. So on the left, we have the number of days of marine heat waves in 2020. In the middle, we have the average maximum intensity of the marine heat waves. And on the right, we have the number of events which occurred. Well, all the figures are for the year 2020. So, well, these figures are very useful, very interesting, and you can identify precisely the regions which have suffered from the marine heat waves. And this is particularly useful because the marine heat waves affect the wildlife, the marine wildlife, the corals, etc. So thanks to this diagnosis, you can identify the regions that should be protected or that you have to check after a marine heat wave. Sorry for this. We propose to use several exercises for with several levels. So for beginners, intermediate users, and experts. And that's it. Again, for these exercises, you do not have the correction, but if you struggle, if you have any question, do not hesitate to ask the question to the service desk. And so that's it for the presentation of the Jupyter Notebooks. Thank you very much for attending this whole presentation. I hope you enjoyed the two exercises, and if you have some question, again, do not hesitate.
Thank you, Ergane. So I think after this huge presentation of the Jupyter Notebook by Ergane, I think it's time for a coffee break and to be ready for the second part of the workshop. You will have a demonstration of the MyOcean Viewer Pro by Chloé after the coffee break, and then QGIS presentation by Simon right after the coffee break. So I propose you 10 minutes of coffee break. So we will be back at 24:11. Okay, thank you again, Ergane.
Thank you.
Okay, we are back for this second part of the day 2 of this training workshop dedicated for the Mediterranean Sea. Now, I'm very pleased to welcome Chloé Durand from the service desk of the Copernicus Marine Service to introduce you the MyOcean Pro viewer. Chloé, are you with us?
Yes, can you hear me?
Yeah, very well. So I'll let you share your screen and start your demonstration.
Okay, do you see?
Yeah, perfect.
Nice. So, hello everyone. I am Chloé working at the Copernicus Marine User Support Team. And I am here today to introduce you our visualization tool called MyOcean Viewer and its main functionalities. It is accessible from the Copernicus Marine Service homepage here, where we offer 3 types of visualization tool: MyOcean Learn, MyOcean Lite, and MyOcean Pro, which correspond to different user level. We have beginner, intermediate, or expert. You have under each version the main differences between each version. So I will quickly show you the 2 first tools, and then we will focus more on MyOcean Pro. So let's open the free tool and begin with MyOcean Learn, the beginner version. Here we can visualize main oceanographic phenomena and parameter. We have sea ice, salinity, temperature, current, chlorophyll, and wave across the time here on the bottom. Only few actions are available with this tool. We can start and pause the video by clicking here. We can move the globe, zoom in and out, and also change to 2-dimension or 3-dimension. But that's all. Now let's go to MyOcean Lite. We have global temperature display by default. We have also other parameters and additional as the pH and dissolved oxygen. We have at the bottom the time axis and the depth axis. You can move on the globe and zoom in and zoom out. You can change the date here by clicking on the axis. The map is update, and then we can change the depth range and begin to see the bathymetry. We have an additional button here to share the link of the page. You can share also an image, a video by setting the start date and the stop date. You can also set the step if you want 1 hour, 1 day, 1 week. We can change the output format in MP4 or GIF and the duration of the video, and also generate an embed link if you want to add in a blog, for example. And so then I will go to MyOcean Pro. We have a default map open, again the temperature, and we have again the axis of time and the axis of depth. If I stay on the title of the layer here, I can see the project ID global analysis forecast phi 001024, the dataset ID global analysis forecast phi 001024, and the variable theta O. We can remove this layer by clicking on the cross here, or hide it by clicking on the blue eye icon, like this. Here we have by default the equatorial projection, but we can also visualize data with a north polar projection or the south polar projection. Today we are interested in the MED, so I will let the equatorial projection. And now we can start to add product and variable by choosing a product in the catalog, and we click on Add Layer here. On the right, we have listed on all the Copernicus Marine product which WMS is available, so around 200 products. And on the right, on the left, sorry, we have the filter to help us to find the data we would like to discover. So this research can be done by inserting a keyword here, or use a filter under. For instance, we have the universe, blue ocean, white ocean, and green ocean. Blue ocean for physical data, white ocean for ice, and green ocean for biogeochemical data. And there's the main variable, the community, the area, the time, sources if you want a numerical model or in situ satellite observation, and under the originating center and the processing level of data. So for the example today, we are interested on the Med-Sea region, so I will check Mediterranean Sea here. We can see here on the left or on the top the number of products which correspond to this criterion. Then let's say we are interested in current velocity, and for instance, I will take numerical model. So we obtain only two products, the analysis and forecast and the Ergane analysis. The first one is for near real-time data, the two last years, and the other one is for older data. Can you mute? Thank you.
Yeah, Chloé, sorry, you can go
on. If you click on the detail button here, you have more information about the product. You have the product ID here, a small introduction and description. You have information if you want to refer to the previous filter we show in the on the left page. Here we are temporal extent and geographical extent, and we have also information as a DOI, sorry. If we satisfy with this product, I click on Add to Map. And then we have listed all the datasets in this product. So we have generally different variable or different temporal and spatial resolution. Here for this example, we have not different spatial resolution, but we have daily, hourly, or monthly mean. We also have data in 2 dimensions and 3 dimensions. The third dimension is for depth. And I will take, as I said, the horizontal velocity daily mean. So I click here and add to map the third layer, seawater velocity. In order to show you, you can add a dataset from a different product. I will come back here and remove all feature. I will select, let me join here again, satellite observation, and I will take, for instance, temperature, because summer is coming. And I will take the Mediterranean sea height resolution and lateral height resolution, sea surface temperature. We have an option here if you want to add this product to your favorite. So I click on the star here, and if I remove all the filter, I go to my favorite and I have my product. Again, we have the detail of the product and we can add to map. Here, for instance, you have different spatial resolution. We have one per 16 degree and 1 kilometer resolution data. I will take the first one and add to map the sea surface temperature. And then I can close this window. Again, I can zoom on the map and move like this. We have again the time at the bottom and the depth. And here we have our 2 layers. Now I will go to several functionalities about the what is displayed on the map. So here we have map customization. We can increase or decrease the opacity of the layer if you want to see the layer under. We have the I button to show the description of the product as we had previously. Here I can explore other layer in the dataset, in the product, sorry, and to see the other dataset. Like this. I have a log button if you want to display the variable in a log scale or not. And here we can configure the layer by setting another color map. I will take this one and set the minimum and the maximum. I will take, for instance, 288 and here 308. We go in June. Right, maybe it'll be better. For other variable as velocity, I can drag up if you want to see the velocity on the top. I have also an option if I want to see a map like this in solid style or if I want to see vector, I can click on vector here and I will have arrows. Sorry, it's very little. And we have here the arrow corresponding to the color map here. Then we have other functionalities on the right. We can add several objects on the map as a point, a line, and an area. If we have finished to plot the area, you have to press, as it is indicated in the blue message, escape button on the keyboard. This. And we have graphics automatically creating for each object. I will move them. This. For They are plotting the variable of interest of the two layers here, but also the variable from the hidden layer. You have for points time series and a depth profile. We have also for line a transect distribution, sorry, a variable and the profile again. And for area, we have histograms. It is possible to add or delete graphic. For instance, I will delete this one and add a new graph. I will take, for instance, the sea surface, seawater velocity, and I want the value. This is time and depth, and click on Add to Graph. I have a figure like this one. On the bottom page, you have also another button about the general setting of the map. You can show or not the base map, show the graphical, and change the projection if you want north polar or south polar, as I said previously. You can also change the units if you want miles or kilometers. And that's all. We can log in and log out like this. If I change the time on the bar here, you can see the graphic are automatically updated. If I zoom on the bar here, I can increase the velocity if I want to select a specific time, and I can reset the zoom to reset the zoom on the axis. These graphics are available to be downloaded and export as a CSV file. But please note this CSV file is only a sample of the data. Even if I increase the resolution, I can increase the resolution here and export sample to CSV. I will open. You can see here I have one data per more than 20 days. So it's only a sample and not the actual data, because actual data are daily data. And close this CSV. Then also we can share the link of the page. Is exactly the same menu as the one we have in MyOcean Lite. And then the last important functionality is the download process, available in the download icon here. We can define the geographic area by setting the value by new home on define, or clicking on define on map and drag the area like this. We can also click on define on map and select an area that already existed. And we can define the date range, and if it is available, I will show you this one. We have the elevation range. Here we have the size of the output file, and if I exaggerate a bit, click on the calendar, we'll go. To May. You can see here a red warning that indicates you the you have exceeded the limit of the 1 gigabyte file. And we can't download if you exceed the limit. So I will come back in to 2021, July, and takes only 1 day. You have two ways of downloading the data by using the show API request here, and we have the Python module client command line. You can click here to have an article about the requirement to use module client in your help center. And then you can also download data by clicking on the download button here, and we will have .cdf file. Only on the CDF file is available with this download process. If I define a subset on map, click like this, and if I choose to change the variable, don't know, I will take potential temperature, daily mean, click on this one. And then if I come back here, you can see the subset is exactly the same. And if you want to download several data in the product, the subset is kept. We have other download services available by clicking here. And we will have the product page with a data access page. We have here listed all the possibility of download and all the data sets. We have the documentation with the product user manual and the quality information document, and again, information about the product. In any case, if you have question, issue, or you need anything, we are at your disposal. So do not hesitate to contact us via the chatbot. We'll come back here. The chatbot here. Mine is in French. You can search an article by clicking here, inserting a keyword, and we will have information, for instance, about WMS. Yes. And we can you can send us a message here. You can also, if I go back here, use this button to talk to an expert, and we have the same chatbot. You can also use the contact us button here, and we will answer you as soon as we can. So thank you for your attention.
Thank you, Chloé. Thank you very much for this demonstration. I hope you enjoyed this demonstration of this powerful tool to access the different products. I think we have some questions. I will share my screen and I will let Ergane ask you the question. Okay, so this is a question in French. Sorry, Ergane.
It's okay. So the question is about reducing the resolution of the sea surface temperature data. Do you know if it's possible in the MyOcean viewer?
The project, if you go here, no, sorry, here, you can see we have
we cannot see your screen, Chloé, sorry, because
Fabrice
is
if I select the data set, the other data set in the product I choose, and I have only 1 degree per 16 or 1 kilometer, but there are all other products with other resolution in the catalog.
Yes, we cannot change the resolution of the product
Yes.
on the viewer. We can just show the product as it is on the viewer, and if you want to increase or reduce the resolution of your product, you have to make some downscaling up or upscaling. So it's completely different.
Okay, so the second question is about the sea surface temperature again. Is it possible to change the units from Celsius degrees, well, to Celsius degrees instead of Kelvin degrees?
No, because again, the dataset is as a setting with Kelvin and not with the Celsius. So if you have a dataset with Celsius is good, but if you have Kelvin, you have to do the transformation by your.
But as yeah, and as the viewer is constantly be updated, this is something we can add for the future features of the viewer. So this is a good remark, and perhaps it will be taken into account in the next version of the viewer. And last question, because we have a lot of presentation with Simon.
Do you know how we can zoom in and out with Mac?
I don't have a Mac, so I don't know.
So perhaps we will be able to answer this question after the webinar, when we will find someone here at the office who can make this demo. Okay. Thank you very much, Chloé.
Thank you.
Thank you.
So now it's time to welcome Simon from Noveltis for the QGIS presentation. I think there is two parts. The first part dedicated for the beginner people, and on the topic of the Medicanes, so the Mediterranean hurricanes. Simon, are you there with us?
Yes, hi.
Hi, Simon. And then after we will make a short Q&A session, and you will introduce the QGIS tutorial for the advanced people.
Exactly.
On the upwelling. Exactly. Okay.
Yes.
The floor is yours.
Okay, thank you. So hello, everyone. So my name is Simon Boitard, and I work as a remote sensing engineer at Noveltis. So today we'll be together for approximately an hour. And the goal is for me to show you the basics of QGIS for ingesting, displaying, and processing Copernicus Marine Service products, and show you some applications that you can achieve in the Mediterranean Sea, and how to use the NetCDF to GIS plugin. So I'm going to share my screen, and I need to find where is QGIS. Okay. Okay, so now you should be able to share my screen, to see my screen.
Yes.
Okay, thanks. So, yes, so I'm just going to start with a quick introduction, telling you about the products and the plugin, and then we will start the practical part of this training. So the Mediterranean Sea is an almost enclosed sea bordered by the European continent to the north and the African continent to the south. To the west, it is connected to the Atlantic Ocean by the narrow Strait of Gibraltar. So the Mediterranean Sea represents less than 1% of the world's ocean surface, but it is one of the busiest seas in the world. It carries 20% of the world shipping and welcomes more than 200 million passengers every year. So this concentration of human activities has a great impact on its rich ecosystem. Indeed, the Mediterranean Sea is home to more than 10,000 marine species, 25% of them being native of the area. So this fragile equilibrium is now threatened by the pollution, noise, fishing, and global warming, amongst other factors. On top of that, natural disasters such as Medicane's phenomena are also a danger to the marine wildlife and the human activities in this populated area. For example, the Ianos storm occurred in between southern Italy and western Greece from September 17th to September 18th, 2020. So in this context, the operational, precise, and reliable Copernicus Marine Service products for the Mediterranean Sea are a great asset to analyze and forecast the health of this area. They are also of a great help to monitor and assess the impacts of traumatic meteorological events, such as the Ianos Medicane. So one way of carrying analysis and getting the maximum out of the CMEMS product is to exploit them in a GIS software. So as I was explaining earlier, this short tutorial aims at demonstrating the processing of the Copernicus Marine Service products for the Mediterranean Sea in the QGIS software using the NetCDF to GIS plugin. Okay. So after presenting succinctly the products that we're going to use, I'm going to explain the basics of QGIS and the use of the plugin to conveniently import Copernicus Marine Service products. And then we will analyze the sea wave height induced by the Ianos Medicane, and the sea wave height variable contained in the Copernicus Marine Service products will help us to follow the trajectory of the storm. Eventually, we will check how the wind speed and direction match the areas of maximum wave height. So just in case some of you are not necessarily familiar with GIS, so GIS stands for Geographic Information System, and there are software applications that provide the ability to present and analyze spatial and geographic data, such as digital maps or geolocalized data. So the data provided by the Copernicus Marine Service portal come in a NetCDF format, which is a common data format that can handle several complex variables. And my colleague Ergane has told you much about that in the Jupyter Notebook presentation. So in order to use these Copernicus Marine Service products, Noveltis has developed a QGIS plugin called NetCDF to GIS, which will enable us to easily deal with NetCDF timeframes and depth levels, and to operate some advanced functions on NetCDF files. So if you are not familiar with this plugin, you will be able to find it at the following address, and there you will be able to download the archive of the plugin and also download the user manual, which will which is a step-by-step guide on how to set up the plugin in the QGIS environment, and it also gives you some solution on the most common error that you may face during the plugin installation. Okay, so using this plugin in the QGIS software, I'm I'm going to show you how to conveniently ingest various types of Copernicus Marine Service products for the Mediterranean Sea, create maps and animations out of the Copernicus Marine Service variables, analyze the sea wave height induced by the INS Medicane, follow the storm trajectory by spotting the areas of maximum sea wave height, and export this trajectory as a new shapefile layer. And we will also follow the wind strength and direction in the hurricane and check how they match the areas of maximum wave height. And also, I forgot to mention, but if you have any question during this presentation, do not hesitate to ask them on Slido. There will be some time dedicated after the tutorial to replay them and some extra session later on. Okay, so for this tutorial, we are going to work with two Copernicus Marine Service products. The first one is the Mediterranean Sea Wave Model Reanalysis product. So this product with this identifier. So this product has a spatial resolution of approximately 4 kilometers. It is distributed on an hourly time basis, and we have downloaded the product in between southern Italy and western Greece from September 15th to 20th, 2020. We'll also work with the global satellite wind observation products with this identifier. It has a coarser spatial resolution of 1/4 of a degree. Sorry about that. And we have, it is distributed as 6 hourly mean, and we have downloaded the variables from September 15th at 12 p.m. to September 22nd at 2020 at 12 p.m. So for those of you who are not necessarily familiar with the data download, in the previous session, Ergane showed you various ways of downloading the products, and there are also some former tutorials that are available showing you how to download the product through the subseller. So in our case, we have downloaded both products through the graphical interface. Okay, so now let's move on to the practical part on QGIS. So first thing you need to have on your computer is the QGIS software installed through the OS Geo. And then you need also to have the plugin installed on QGIS. So in order to install this plugin, I showed you the web page earlier. Once the plugin archive is downloaded, you can go to plugins, manage and install plugin, and install from zip. And from there, you can follow the step-by-step PDF tutorial in order to conveniently install the plugin. So once all of these basics requirements are fulfilled, you can create a QGIS project. So project new, here it's already created, and I have called it a QGIS demo. And you need to set a coordinate reference system for your project. So for this tutorial, we will use the classical WGS 84 with the EPSG 4326. Okay. Then the main strength of using QGIS is to display the Copernicus Marine Service products in a geographical context. So the first thing you want to do when working with QGIS is to import a convenient background layer. So there are several ways of doing so. Here we're going to...
I'm sorry to interrupt you, Simon, but we can't see the plugin window. I'm not sure if it's on the right screen.
I'm not using the plugin right now.
Okay,
so...
but it's all white. Is it normal?
Yes,
that...
yes,
okay.
Yes, thanks. The first thing you want to do is to load a a map background. So here I'm going to show you one way of loading a map background. So here you can go to layer, add layer, and add a WMS layer. So we are going to load our map background from a WMS server. So here we are going to load it from the map server demo. Here I can show you the detail of the connection. So here I've just given a name to the connection and simply used the following URL to connect to the WMS server. You don't need any account, okay? So here I'm connecting to the WMS layer. And here several layers are available to you. I'm simply going to load the blue marble background layer. So hit add and close. So now you have a nice map background. Today we're interested in the Mediterranean Sea. So let's simply zoom into the Mediterranean basin. It takes some time to load, but then you should have a better resolution over the area. Perfect. Okay, so now that we have set a CRS and a map background, we are going to import the Copernicus Marine Service products in our QGIS projects. So to do that, let's hit on the NetCDF to GIS icon. So for now, it's blank. First thing we want to do is to import a product in the NetCDF to GIS plugin. To do so, hit the little plus button over here. And here, of course, it will depend on your working environment and where you have stored your input data. Here, I have stored it in QGIS demo input data. So I'm first going to load the global wind product here, open. And then I can also load the wave product here. I'm going to open that. If you want to open multiple products at a time, you can simply go within input data, select both products and drag it and drop them to the plugin window. Okay, so once a product is imported within the plugin, you have access on the right panel to several pieces of information on your data. So in the variables tab, you will find information on the name, dimensions, unit, and long name of each variable of your NetCDF product. So here you can see, for example, northward wind, wind speed, eastward wind. You can see the dimensions they depend on and the unit. It's similar to Xarray in Python. Then in the metadata tab, you will find elements on the dimensions of the file. So here 29 time frames, several latitude and longitude cells. And you will find also global attributes. For example, when the project was created, when it was modified, who's responsible for producing the products, etc. In the option tab, you can choose and set the display prediction of the selected variable and your working directories. And finally, in the About tab, you will find general information about the product itself, the plugin itself. So during the training, we will work with the sea surface wave significant height, and we will also work with the wind speed and the northward wind and eastward wind components. Okay, so let's start working with the sea surface wave significant height. So for our first product exploration, we will display the significant wave height from the Mediterranean reanalysis model product of the Copernicus Marine Service with a 4-kilometer horizontal resolution on an hourly basis. So here, from the variable panel, you can select the sea surface wave significant height, right-click on the variable, and select the sequence layers option. From there, we will only select a subset of the available time frames in our product. So we will have a closer look at the time window defined in between September 17th and September 18th. So we will select the following time frames. September 17th at 6 a.m., September 17th, 12 p.m., 6 p.m., September 18th at 12 a.m., 6 a.m., and 12 p.m. Here, why do we select only one time frame every 6 hours? It's because the wind product that we will use later on as is 6 hourly. So it's to have concomitant time frames in between the wave reanalysis model and the wind speed global products. Once all of your time frames are selected, you can hit the little start button here. And here you can see each time frames displaying one after the other. So here, I'm sorry, I made a little mistakes because the time frame from September 15th is selected. So I'm just going to do it again. Okay, sequence layer. Here I just need to make sure correct time frames are selected. Okay. 6 and 12 and no 15. Okay. Okay, here. And so you can see all individual time frames displaying one after the other. And you can actually already sense how we will be able to follow the Medican trajectory based on these values. So once you're done with the animation, you can hit stop and close. Okay. Okay, from there, we can expand a little bit more what's available in each layer. And you can see that the color scale is not really appropriate and does not tell us a lot about the values that we're seeing in our products. So we are going to tune the color scale. For this, right-click on the layer and go to Properties. In Properties, make sure to be in the Symbology tab. There, you'll be able to define the minimum and maximum of your layer. So here, we'll set the minimum of the significant wave height to 0 and the maximum to 4 meters. We'll use the spectral color ramp, but we do not want to have it from red for low values to blue for high values. We want to have it inverted from blue to red. So just hit invert color ramp. In the mode, make sure to select equal interval and define the number of classes to 5 to have one color per meter. Hit apply and OK. So now we have tuned the color scale of a single layer. The other ones are still not perfectly tuned. So what we would like to do is to export the style to the remaining layers. To do that, right-click on the tuned layer, Styles, Copy Styles. And then you can just select the remaining layers and paste the styles. And from there, you can activate and deactivate each layer, and again, scroll through each layers. Okay, and each layer have a convenient color scale. Okay, so here you can see that the eye of the hurricane is easily recognizable with low sea wave height values inside the sea wave height maximum area. So these characteristics will help us to spot the IANOS hurricane trajectory in the following part of this training. Okay, so now we are at the core of the QGIS tutorial, which will be to spot the hurricane trajectory based on the sea wave height variable available in the Copernicus Marine Service wave reanalysis product. So during a hurricane, the sea wave height maxima are located on the sides of the eddy, and the eye wall values are lower. So using this information, I'm going to show you a method to create a new shapefile layer where we can add the position of the eye of the hurricane between September 17th and September 18th, 2020. So first, what we need to create is an empty shapefile layer, which will hold the successive position of the hurricane every 6 hours. So here, to do so, we'll go to Layer, Create Layer, New Shapefile Layer. Okay, just going to. So first, we need to define the file name and the directory where we want to store the empty shapefile layer. So for myself, I will store it in a QGIS demo, IANOS path, and define the IANOS path shapefile. Hit save. I will define the geometry type as points. And then if you wish to, at this stage, you can add all the field, which will be the attributes of each of the points you are going to define. So you can do that if when creating your empty shapefile, you already know the attributes you want to set for each entity. For this tutorial, we are going to leave it empty and then create new fields. So we'll leave it empty, and it's always possible then to edit the shapefile and add anything you want. Okay, so we can hit OK. So here the layer already exists, but I'm just going to overwrite it to create an empty shapefile layer. So you can move it up here. So right now it's empty, there's nothing in there. It's just an empty layer that is going to hold our points. Okay, so now it's time to add point features to this new layer. So from there, you can right-click on our empty shapefile layer and toggle the editing mode, or you can simply select the shapefile layer and toggle the editing mode over there. Okay. And then we are going to add point feature here. Okay, now we are going to scroll over the successive layers and define the position of the eye of the hurricane based on the information available in the Copernicus Marine Service product. So on September 17th, 2020 at 6 a.m., we can spot the eye of the hurricane over here. We are going to set an ID to our point. Here, we are going to start from 0. Hit OK. Then we display the layer the same day at 12 p.m. and set the position. Set the ID to 1. and so on. Set the ID to 2. Three. And 4 here. And then here it's going, oops, it's starting to be harder to spot the eye of the hurricane, as we can sense that he's not fully over the Mediterranean Sea anymore and over part of Greece here, especially on this date. So now we have 5 points defining the successive positions of the hurricane every 6 hours. So you can leave the editing mode and save the changes we have brought to this layer. So now we have a shapefile containing 5 points. What would be convenient as well is to add the dates as an attribute to each point, so that in a single shapefile layer, we have the positions and the date of this position. For that, we'll toggle the editing mode again and open the attribute table. So here you can see our 5 points, and they each have a single attribute, their ID, which is incremented from 0 to 4 by step of 1. So what we are going to do here is to add a new field. We'll name this field dates. So this field will hold the dates of each position. The type will be text. So here there is a date type, but the date type is the precision of this type is limited to days. And here we want to have an hour precision. So we'll set the type to text. Set the length to 16. So it's the length of the field. So the field can have 16 characters maximum. And then OK. Now we are going to edit here the dates field. OK. So to define automatically a field, you can set up an expression here with this button. So from there, I'm going to use the following expression in order to automatically define the date of the positions here. Okay, so be careful when you copy and paste the following expression from the PDF tutorial. You need to replace these little guys here so that it goes well with the QGIS syntax. So what does this expression make here? It works a little bit like what Ergane presented in Python. It's a set of functions that's used to automatize processes in QGIS. So here, with the make date time function, we set up a start date. Our start date will be September 17th, 2020 at 6 a.m. Okay, which is our first time frame. And then for each point, we'll make an interval, a time interval of 6 hours based on the ID of each point. So for the first point, the ID is set to 0. So the date field will be set to the start date. Then the following point with ID 1, the date will be 6 hours later, etc. So to use functions in QGIS, you can find them there. And here I found my functions in dates and times here. So you have a set of functions already predefined for you. And when you hit on a function, you'll have some documentations, how to use it, the arguments you need to define, and the examples of how to use the function. So here we can simply hit OK and update all. And now by scrolling through the points, you can see that now automatically we have defined the dates of each position. So, okay, so you can leave the editing mode, save the modifications, close the attribute tables. And now we can display our dates as labels to our shapefile layers. So here you can go to Properties. Taking some time to open. Okay. Go to Labels, Single Labels, set the value to dates. As we want to have the dates really well and clearly displayed on our map, you can draw a background, set it to white, hit Apply and OK. And here you have the various positions of of the hurricane with the associated dates. Okay, so now we are done with defining the successive positions of the hurricane using the sea wave height field, the significant wave height, sorry. Can just, okay. So now we are going to play around a little bit with the wind field that's available in the global wind observation products. These products over here. So we can load the wind speed variable here and hit add layers. So now you understand better why we have selected specific time frames in our significant wave height variable, because here we're going to work with the time steps from September 17th at 6 a.m. to September 18th at 12 p.m. Those time frames. You can hit add and close. Okay. So here you can move this up a little bit over here. Okay. As for the wave height, we're going to tune the scale from 1 to 17 meters per second, invert the color ramp, apply OK. Then by scrolling through the individual time frames, one after the other, you can follow the wind speed every 6 hours. And you can already see that it corresponds pretty well to the positions that we have defined using the significant wave height. You can also see, for example, if I focus on the wind speed on the 17th of September 2020 at 12 p.m., that the product resolution is way coarser than the significant wave height. Okay. Okay, and one thing I forgot to do here before scrolling is to copy the style and paste it to the remaining layers. And now you will have a more consistent display here between all layers. Okay. So now one last thing I'm going to show you in the frame of this beginner tutorial is how to display vector field within QGIS using the NetCDF to GIS plugin. So let's go back to the plugin window here on the wind product. So here we are going to load each component of the wind within QGIS before vectorizing both components. So here, again, right-click on the eastward wind variable, hit add layer. Here, as it's just a demo, I'm going to focus on one time frame, but feel free to do it for other time frames as well. On September 17th, 2020 at 12 p.m. You can add and close. Do the same for the northward wind component. Make sure to select the same time frame, otherwise you will not have consistent wind vector field. So here, September 17th, 12 p.m. Add and close. Okay. Now you can see that both layers have been added to our QGIS project and to the Layers tab of the QGIS plugin. So now you can select both components and hit Vectorize. So here, make sure that the east-west layer corresponds to eastward wind and north-south layer correspond to northward wind. Check one last time that the dates and times are consistent. Set the output directory. Here I'm going to set it here and call it wind vector IANOS 17 September 2020 at 12 p.m. Can hit vectorize. Yes, you can hit vectorize and close. One last step. So now you can see that the vectors are conveniently displaying. One last step is to set a proper style. So we'll do it this time by loading a style that is predefined and that you can download with the training kit later on. So here you can go again to symbology, style, load style, from file, here, wind field style, open, load style, apply, OK. So now there's a better style with a nice legend in meter per second. Okay, and now if you superimpose this wind vector for September 17th at 12 p.m. and you also superimpose this with the wind speed. So you can see that this is the position that we defined on September 17th at 12 p.m. based on the sea wave height. And this is the wind field. Behind that is the wind speed. And if we deactivate the wind speed, you can see the significant wave height field here. Okay, and so you can see that all three variables are very much in line with each other. So we have defined a pretty accurate trajectory of the IANOS Medicane here. So this was the end of this beginner tutorial on QGIS for the Mediterranean Sea. So just to wrap up this part of the session. So in this training, we used the NetCDF to GIS plugin to handle and visualize Copernicus Marine Service model products and observation products for the Mediterranean Sea. So it enabled us to display the significant wave height variable to define the positions of the IANOS hurricane between September 17th and 18th, 2020. And then we checked that the position we had previously defined based on the significant wave height were accurate using the wind vector field from the satellite observation data. So this scenarios is workable with other hurricanes in the Mediterranean Sea or other parts of the world. And of course, feel free to visit the Copernicus Marine Service and download other Copernicus Marine Service data to map them on QGIS. So I think I can stop sharing my screen for now and take maybe some questions.
Yes, thank you, Simon. So yes, we have some question for you on your demonstration. I will share my screen now. Okay, do you see my screen and the question?
Yes, I can see that. I can see them.
Okay, so there is a question here. what are the different benefits and disadvantages that characterize QGIS and MyOcean Pro?
Okay, so I would say, but then of course maybe Chloé will be able to add more details later. So I would say that QGIS can be actually used to process the data and to also export the data to various data format. Like, for example, one very nice advantage of QGIS is the ability to manipulate, create, work with shapefiles that are vector layer that can hold several attributes and are very, very convenient to carry out GIS analysis. So really, QGIS is very convenient to is a very convenient software to carry out GIS analysis and create really nice maps.
Yes, you can make computation between the different layers.
Yeah,
you can add different sources of products and data. This is not the case with MyOcean Pro, because MyOcean Pro is just plugged to the Copernicus Marine Service catalog. But if you want to manipulate different data from other sources, I think about EMODNet, for example, with protected marine areas, layers, something like that, you need to use QGIS. So MyOcean Pro is just a tool to discover the data, to start playing with the data, but it's limited, very limited. And if you want to go a step further and try to make some computation between the different layers and add other data, you have to switch on QGIS.
Yes.
Okay, thanks,
Exactly.
Simon. Okay, some people add an error when they try to load the plugins. So I put on the chat, on the discussion, the correct link to download the version, because if you have this,
okay.
I think this is an error due to the version of QGIS.
So either to the version or either from what kind of setup QGIS was installed from, because I can see an OSGeo root issue.
Yes.
So maybe QGIS was installed another way, and that's why the plugin doesn't work at this stage. So maybe I would advise you to try to set up another instance of QGIS on your computer using the OSGeo way, and then try again to set up the NetCDF2 QGIS.
Yes, I put the link on the chat. So this is not a question of version, but just a question of the way you install and the plugin, the QGIS. Okay, thanks. Is it possible to integrate the plugin into a QGIS model to automatize processes and iterate through files folders? Is there any material tutorial on this?
So that's a good question. So I don't think that the plugin can be used automatically. I mean, at least not the graphical interface. Maybe I would suggest, I'm not sure about that, but maybe you can dive into the source code of the plugin, which is, I think, should be available in the archive, and try to adapt that to develop your own routine and your own thing, your own plugin to automatize what the graphical interface of the NetCDF2 QGIS plugin does.
And in general, it's possible to create some macro on QGIS to automatize some.
So I think it's possible. I have never done it myself, but I think if I remember well, I have seen some people doing so before.
Okay.
But then you will you need to like, I think, have some knowledge on Python.
Yeah.
So
Okay. And last question, please, where can I download the shape files of the world?
I think that maybe if on Google you type word boundary or shapefile, you should find some material there. Like on top of my head, I don't have a precise website to recommend, but I'm sure you can find it if you perform some digging in Google. I can look it up later.
Okay, and there is a new question. Okay, how do you save your last plot?
How do I save the last? Sorry. So the last plot. This. I think you can view. You can save. If I am not wrong. So I think that what I do usually is take a screenshot, but I think there are other options available within QGIS where you can actually like create map backgrounds, etc. I just don't remember precisely how to do that.
Perhaps we will put the information later on the Q&A file.
Yes.
Okay.
Yes. But the simplest way is to take a screenshot, I would say.
Yeah. Okay. So I take just one or two questions more. When did you select the coordinates of the study area?
So I selected the coordinates of the study area when I downloaded the products, so that it was already subsetted to a convenient area. But in the advanced scenario, we also show you a way of subsetting the coordinates, the area of interest directly on the QGIS.
So this is on the second tutorial on QGIS, available soon with a video tutorial through the Padlet. And is it to have a video format output from QGIS?
So I'm not sure about that. I don't think so. But what you can do is, again, take a video screenshot to export the animation conveniently.
Okay. But we can make animation on QGIS?
So we can display animations, as I showed during the tutorial, thanks to the plugin.
Yeah.
But I'm not sure there are a predefined functionality within QGIS to actually export directly in, for example, MP4 or MKV or such format.
Okay, I think we're going to stop now. Again, all the questions will be answered on the Q&A document, and you will access all the answer later, soon after the webinar. You have some minutes to introduce the advanced QGIS tutorial if you want, Simon.
Okay, so let's go if you're still with us. So
yes.
Okay.
Around 200 people are following us, are still here to hear you.
So let's go back to my screen and to QGIS then. So the second tutorial is about studying upwelling events in the Mediterranean Sea, and more precisely along the Adriatic coast of Italy. So for those of you who are not necessarily familiar with what an upwelling event is, Upwelling is an oceanographic phenomenon that involves wind-driven motion of dense, cooler, and nutrient-rich water towards the sea surface. And this kind of event replaces the warmer and drained surface water. So the nutrient-rich upwelled water stimulates the growth and reproduction of primary producers, such as phytoplankton, and provide food for fish, marine mammals, and birds. And so upwelling generates some of the world's most fertile ecosystem. And they are also very well captured from space when there are no clouds. I can show you quickly the picture from the step-by-step tutorial. So this is a cloud-free Olchi on board Sentinel-3 pictures of the Adriatic Sea upwelling that we are studying in this advanced scenario using the Copernicus Marine Service products. Okay, so in this scenario, we will use several Copernicus Marine Service products for the Mediterranean Sea. And in particular, we will use the Mediterranean Sea Physical Model Reanalysis products that has a spatial resolution of 4 kilometers. The values are distributed as daily means. And we have downloaded the products from November 15th to 25th of 2017. So this product will be used to study the sea surface temperature and see how the upwelling event takes place, and study the extent of the upwelling event along the Adriatic Sea coast of Italy. Then we will also use the Mediterranean Sea biogeochemical model product that has kind of the same characteristics of the physical model reanalysis products. It has a spatial resolution of 4 kilometers. The values are distributed as daily means. And again, we have downloaded the product from November 15th to 25th of 2017. And finally, we will also again have a use of the global wind observation products. Why the wind? Because upwelling is a wind-driven phenomenon. Okay, so what we will do basically during this scenario is study first the sea surface temperature and see the cooling of surface water. Following this, we will study the chlorophyll concentration, and we will quantify the chlorophyll bloom that is subsequent to the upwelling of cooler and nutrient-rich waters. And we will also, again, plot the wind vector field in order to see what kind of wind conditions can trigger an upwelling event. So here, I'm just going to go into more details on one step of the advanced scenario, which consists in displaying the sea surface temperature. So for that, we will again use our plugin, and we will import a new product, which is the Mediterranean Sea Physical Reanalysis model holding the seawater potential temperature in degrees Celsius this time, not in Kelvin. Okay, so from there, we can map the sea surface temperature as we did earlier. So we can, again, sequence layer to display an animation, select all layers, and hit start here. You can see the animations one day after the other displaying. And you can already see here, especially over northern Italy, the cooling of surface water over there. Okay, so we can just stop the animation, close the window, as introduced earlier, we can define a convenient style. We'll define minimum from 13 to 22 degrees Celsius. Apply and OK, and we can apply this style to other layers. And so here you can really see I forgot to do something over here. I forgot to invert the color ramp. Okay, doing it again. Okay, and here you can see in a consistent way the cooling of surface water. Oops. Okay, especially between here and there. Okay. Now, what we do in this scenario is to restrain the analysis to a polygon that is defined over Italy, over the Adriatic coast of Italy, and isolate the area where the sea surface temperature is below a defined threshold. So first, we need to convert our layers to polygons. So convert them to shapefile, basically. So to do that, we can go to raster, conversion, polygonize. We will perform that on 2 layers. So the sea surface temperature on the 18th of November 2017. We will name the temperature of the field to create temperature, and we will store the file in output, this shapefile. Okay. Okay, then you can hit run. And we can do it again for the 24th. Define here, just change the date. Can hit run again. Okay. So here, if you move that up a little bit. Okay, for more convenience, I'm going to shut down those layers. Okay, so now you can see that our raster layers have been converted into polygons. And if you hit this little guy here, information button, you can have more information about the field. Okay. And from there, you can filter. Here, filter. So here I forgot to rename the field temperature, so it's called with the default name DN, but it's the temperature. You can filter that in between 0 and 14 degrees Celsius to isolate. And we can apply that on both layer, filter, temp. Okay. Now you can see that the data have been restricted to the areas where the sea surface temperature was in between 0 and 14 degrees Celsius. And so you can already see that here in between November 18th and 24th, the area where the sea surface temperature was below 14 degrees Celsius has significantly increased. Following that, when converting from raster to shapefile, some geometries can be corrupted. So if you want to have a sound shapefile, we highly advise you to go to processing toolbox and use the fix geometries tool. So let's run that on both layer. Can save it there. Yes. Okay. Run. And let's do it again for 24th. Just change the date. Okay. And run. Okay. After that, we will use a polygon that we have defined of the Italian coast here. So it's a polygon that I have created ahead of time using the layer, create layer, new shapefile layer, but rather than having a geometry type set to points, I set it to polygons. Okay. So here I'm just going to change the style. Okay. Okay. And from there, we are going to perform an intersection between this polygon and these polygons in order to get rid of this area that we're not interested in. For that, go to Vector, Geoprocessing Tools, Intersection. The input layer is the Italian coast polygon, and then we use, for the 18, we use the fixed geometry. Save to file. Okay, yes, run. And we do it again for the 24th. Here, we just change the name over there and run. Okay, so if we deactivate, you can see that we got rid of what we didn't want to. Finally, we are going to merge all single polygons with different fields according to what was the temperature into a single polygon. So for that, you can go to raster, geoprocessing tool, dissolve, and perform the processing on both layers. Save to file. Okay. Okay, run, and do it again for the 24th. Here, change the name. Okay, run, close. So now you can see that we have a single polygon per date. Okay. And what we're interested in is computing the area of each polygon. So for this, you can toggle the editing mode. Go to open attribute table, field calculator. We're computing an area in kilometers squared. And here simply write the following expression. Okay. We'll do that for both. Okay. So we can see that approximately 9,400 kilometers squared of the area were below 14 degrees Celsius on November 24th, while only on the 18th, you can do the same. Here, area squared. Okay. Okay. Save here. Okay. And here, if you hit here, you can display the area in kilometers squared for both layers. Okay. So you can see that in a week, the area where the sea surface temperature was within 14 degrees Celsius has almost tripled, which highlights the upwelling phenomenon. Okay, so if you want to study more in depth the upwelling phenomenon, you can follow the rest of this tutorial on the video and the step-by-step PDF guide. So it was just to give you a little tease of what's offered in this tutorial. So I thank you for your attention again, and maybe I'm going to take some more questions.
Not for the moment. I think
moment. Okay.
we finished. I close all the session on Slido and put the question in archive to let the expert answer the question. So don't hesitate to have a look on the question and answer for this. Thank you very much again, Simon. I think this is the end of our training workshop this second day. Let me share my screen because this is not our last meeting. Because we look forward to seeing you for the debriefing session the 31 of May. What message we have for the participants? All the material is available on the Padlet. If you have any question, don't hesitate to contact the service desk. Thank you for the participants who answered some question on the chat, or you have shared your tips and tricks on the chat. Thank you very much. Thank you to all the experts. Thank you to Simon and Ergane from Noveltis to have prepared all the material. I hope you will enjoy use it and play with it. Ergane, few words.
Just maybe add that we will come back for the debriefing session. The aim of the debriefing session is, well, you have 2 weeks to go through the exercises, to have a look at your needs. And on the debriefing session, we will take time to answer your questions and maybe to go deeper in the exercises. So do not hesitate to come back. We will also answer the questions that were not answered today. So yes, do not hesitate to come back. We'll be happy to see you.
Yes, and I see on the chat some question about the certificate of attendance. We will provide this kind of document after the debriefing session, so start of June. Okay, it's time to lunch now. No?
Yes.
Yes, after these 3 hours of training workshop for the Copernicus Marine Service dedicated on the Mediterranean Sea. Thank you very much for your attention, and see you.
See you. Bye.
Bye.